Moving into chapter 9, the things that we're going to take a look at here are going to be multiplying, dividing, adding and subtracting with a bunch of x's and y's and x squareds and x cubes and all that. And then we're also going to talk about solving those if they're in fractional form. So basically we're going to be working with a lot of fractions, dealing with x's, y's, x squareds, y squareds. So to start out, before we get into the notes here, which don't forget are on my webpage, if you didn't get them in class, you can print them off. But just in case, let's talk about some things to remember about factoring before we get started. Because if you can't factor, then you're not going to be able to do anything that we're going to do here the next few days. So let's start with the number one thing to remember about factoring, and that is you always look to take something out. Meaning you have to look to see if everything has something in common, and if it does, then you take it out. What do I mean? Like a 6x plus 3. Since these both have a 3 in common, you can take a 3 out and you're left with an x plus 2. So that's always number one. Now, once you do that, you're going to be left with either 2 terms, 3 terms, or 4 terms when you're done. By 2 terms, maybe you get something like x minus 3, or maybe you get an x squared plus 6, or maybe you get an x squared minus 9, or something like this, where you have 2 things left over. This one, this x minus 3, can't do anything with that. There is no way to factor that. The x squared plus 6, because this is a plus, there's no way to factor this. But if you remember, back to chapter 6 videos, dealing with factoring, this is what we call the difference of squares, because this is a perfect square, this is a perfect square, and it's a subtraction in the middle. So if that is the case, then that will factor in x plus 3, x minus 3. So watch for these perfect squares if you have 2 terms left. If you have 3 terms, like if you had x squared plus 8x plus 12, or maybe you had a 2x squared plus 4x minus, I don't know, we'll say 3. Don't forget here that you factor this, and you're looking at this back number, and you're trying to get factors of 12 that'll give you 8. Since these signs are both plus, these signs both must be plus. We have an x and an x. And factors of 12 that give you 8 are going to be 6 and 2. So I factor into x plus 6, x plus 2. If you have a number out front here and they don't have anything in common, don't forget rule number 1 is taking something out. If these don't have anything in common, then we have to remember our x method, where you take a 2, a 1, and a 3, and a 1, and you sit here and multiply until you get this middle term. That is how you factor with 3 terms. And the last one is if it have 4 terms, maybe it's got like x to the 3rd minus x squared plus 2x minus 2. Where this one, if it has 4 terms, if you go back to chapter 6 videos, we're looking at factoring by grouping, where you group these first 2, take something out, group these second 2, take something out, and then you put these 2 together. So just a few reminder rules on how to factor. So what I want to do, I'm going to go over on page 1 in your notes. I'm going to very quickly go over these warm-up factoring problems. If you are not sure about factoring, why don't you pause and try these on your own and then check them and restart the video. Otherwise, I'm going to do these fairly quickly because factoring shouldn't be that difficult for us anymore. So let's go with this x squared plus 3x plus 4. Factors of 4, that'll give me 3, are going to be 4 and 1. Since this is plus 3, I know this has to be plus 4, x minus 1. Why? Because plus 4 minus 1 is 3, and plus 4 times negative 1 is negative 4. Over here, this is going to factor in an x plus 2 and x plus 3, because 3 times 2 is 6 and 3 plus 2 is 5. Here, this is a difference of squares because 4x squared is a perfect square and so is 9, so this will factor in 2x minus 3 and 2x plus 3. Next, this one here, don't forget rule number 1. These both have an x in common, so I'm going to take that out. When I do that, I'm left with an x, 6x here, plus, if I take an x out of x, there's actually a 1 left over. And the last one, number 5. This is going to go back to chapter 6 as well, dealing with special cases. When you have a couple of cubed terms, like this is actually 2 cubed and this is 1 cubed. If you can't remember the rules, I suggest you go back to chapter 6 videos dealing with factoring of special cases. There will be some cube discussions in there, but the a here is going to be 2x. And the b here is going to be 1. And don't forget, if this is plus right here, it factors into a plus b, so 2x plus 1, parenthesis, if this is a plus, then this is a plus. We have to square this a, which ends up being 4x squared. Since this was a plus, this one here is a minus. We go a times b, which would be 2x, plus this squared, this back part b squared, which is 1. So that is how this factors. Don't forget this back part here, this, will never be able to be factored any lower than what it is right now. So there's a quick warm-up. Here's a quick review of multiplying and dividing fractions. We'll get into adding and subtracting in the next one. Here's going to be my suggestion for you. Number one, if you see a problem like this where you have a bunch of stuff on top and maybe you even have a bunch of stuff on the bottom, you need to treat this as two separate problems. Meaning I'm going to do the top all by itself, then I'm going to do the bottom all by itself, and then see if I can put them together. Like, I'm going to go 1 plus 7 here, which should give me 3 times 8, and 3 times 8 is 24. And then I'm going to treat the bottom all by itself as one problem, and now I'm going to see what I can reduce. I can divide both of these by 4, so I get 6/5. So that is hint number one. If you have two things on the top and the bottom, treat them as two separate problems. Here's going to be my next hint. And if you have two fractions that are being multiplied, yes, to multiply fractions, you do simply go straight across here. You could do that, and you get 15 over 120. And rather than reduce 15 over 120, here's my next hint. If you have two fractions that are being multiplied, this doesn't work for adding and subtracting. It does work for multiplying. If that's the case, you're going to look to cross-cancel. What I call cross-canceling. Meaning I'm going to look to cancel diagonally. Like 5 and 10, since those can be divisible by 5, I'm going to do that. 5 divided by 5 is 1, 10 divided by 5 is 2. And I'm going to do the same thing with 3 and 12. I'm going to cross-cancel those, so I end up with a 1 here and a 4 here. And now I can multiply straight across. 1 times 1 is 1. 4 times 2 here will give me 8. And then I don't have to do any kind of reducing. So always look for this cross-canceling. And the last thing we have to remember about dividing fractions is when you divide fractions, you don't technically divide, you multiply by the reciprocal. Meaning I take this second one, it's always the second one by the way, never the first one. I'm going to take this 3 over 2 and go multiply by 2 over 3. I'm going to look to cross-cancel. Why? Because they're two fractions being multiplied together. Cancel these two to give me a 3 and a 1. Cancel these two to give me a 7 and a 1. Multiply straight across and you will get 3/7. So there are some fraction hints. Now let's go down below and let's take a look at some examples. All right, here's example number 1. These are going to be done a little bit different than this one over here because this example 2 and example 3 has a bunch of pluses and minuses in it. So we're going to do those a little bit different, but let's take a look at example 1. Example 1, I am going to think about this as being, get my line tool out here, I'm going to think about this as actually being one giant fraction. Because then I can see what I can combine and what I can't. Don't forget your rules from up above about cross-canceling and treating the top as one separate thing and the bottom as one separate thing. So here we go. Number 1, I'm going to take care of all of these numbers first. And by numbers, I mean coefficients. I'm going to take care of this 5, the 6, the 2, and the 10. I'm going to take care of those first. And since I can cross-cancel because these are being multiplied, I'm going to go 5 and 10, cancel me 1 and 2. 6 and 2 will cancel me 3 and 1. So I know in my final answer, if I go straight across, I'm going to go 1 times 3, which is 3, over 1 times 2, which is 2. I know that's going to be in my final answer, and now I don't have to worry about any of these numbers anymore because I took care of them. Now I'm going to treat the top as its own separate problem and the bottom as its own separate problem. I'm going to go straight across here and see how many x's and y's I have. So I have x squared times x cubed, that's 5 of them. I've got a y times y squared, that's y3. On the bottom, I have 1x left, and I have y cubed times y, which is y to the 4th. Now what I'm going to do is I'm going to cancel straight up and down here. I still have my 3 and my 2. Don't lose those. I have 5 of them on top, 1 of them on the bottom, so there's 4 left on top. And I have 3 of them up here, 4 of them down here. There's 1 left down there. Final answer, 3x to the 4th over 2y. Now, this one over here is going to be a little bit different. Let me first start off by telling what you cannot do. And this is going to be the number 1 mistake made by almost everybody. And it's going to stress me out here eventually. This x squared and this x cubed cannot cancel out. Nor can this x squared and this x squared. When there is pluses or minuses in your fraction here, you can't just start canceling things like we did right here. You can if it's multiplying, but you can't if it's adding or subtracting. So therefore, none of what I just wrote there is any good. I can't just cancel this x with this one, or I can't just reduce this 6 and 3. Yes, I agree that 6 can divide by 3, but because of these symbols, these pluses, we cannot do that. So here's what I'm going to do instead. I'm going to see if I can factor this top and make it multiplication, because then I can cancel. And then I'm going to factor the bottom, see if I can make it multiplication so I can cancel. So on the top, this is actually the exact same problem as in our warm-up. Number 2 up there on the warm-up. I'm going to factor this into x plus 3 and x plus 2. On the bottom, this cannot be factored in anything, but this and this do have something in common, so I'm going to take that out. I'm going to take out an x squared, and I'm left with an x plus 3. Now that these are being multiplied and these are being multiplied, I can cancel things like this x plus 3 and this x plus 3 because those are the same. So my final answer here, I'm left with an x plus 2 over x squared. You cannot cancel this x and x squared because of this plus symbol right in between here. So I am done. There's nothing else to be canceled. All right, and example 3 before we get to division. I'm going to do the same thing. I'm going to try to factor the tops and the bottoms and see what I can get to cancel out. So let's take some stuff out of this top here. I'm going to take out a 4x from up above. So I have a 4x outside. 4x out of 4x leaves me with a 1 minus x left over because 4x squared divided by 4x is x over an x squared plus 2x minus 3. This will factor into an x plus 3 and an x minus 1 because 3 times negative 1 gives you negative 3 and 3 minus 1 is 2. Do the same thing over here on the side. This is going to factor into an x plus 3 and an x minus 2. And there's nothing to do with 4x on the bottom. Let's start to look, because everything is being multiplied in here now, let's start to look at things we can cancel. Like, I can cancel this x plus 3 and this x plus 3. I can cancel this 4x and I can cancel this 4x. So I'm left with on top 1 minus x times x minus 2. All over. On the bottom, I still have an x minus 1 left over. Now, without getting too technical, since this bottom, I'm going to highlight these, since this and this are very close, the only thing that needs to happen is they need to be reversed. Here is how you can reverse these signs so that these are going to be the same and then they're going to cross out. I'm going to take a negative out of this 1 minus x. Why? Because watch. This is technically a positive 1. And if I take a negative out of a positive 1, that will leave me with negative 1. If I take a negative out of negative x, that'll turn it back to a positive. And now I've successfully flipped those. Don't forget your x minus 2 on top. I have successfully flipped those numbers so that now they are the same. And I'm left with negative x in parentheses minus 2. Distribute that negative in there. Looks like I will get a 2 minus x as a final answer here. If you need to, go ahead and go back to look at that. Look at this little magical part that I did right here. If you need to go back and figure that out, but let me show you one more example. So if you had like an x minus 12, and then you had a 12 minus x, these can be made to be the same by simply taking a negative out of one of them. So if you take a negative down here, that will flip those to be x minus 12 and an x minus 12 up here, and then they will be the same. You can cross them out, and you'd just be left with negative 1 left over. So even though they might not look the same right away, we can pull out a negative to make them the same. All right, flipping it over, let's take a look at division. Division is going to be the exact same thing as multiplication. The only thing I do different is instead of dividing, I'm going to multiply by the reciprocal. That means I'm going to take this one right here, and I'm going to flip it. This back fraction, I'm going to flip it to be the reciprocal. So I end up with an x squared minus 6x plus 8 over x squared minus 2x. I'm going to factor the top and the bottom just like I got done doing in those 3 examples before. So the 5x can't do anything with that. On the bottom down here, I can take out a 3, and I'd be left with x minus 4 because these both have a 3 in common. Times the top, I'm going to factor into x minus 4 and x minus 2. Bottom, I can take out an x, and there will be an x minus 2 left. Now I'm going to start looking to cross cancel, meaning this x minus 4 and this x minus 4 can cross out. This x minus 2, this x minus 2 can cancel out. And because these are being multiplied right here and right here, this x and this x can actually cancel out as well. So you're left with a 5 on top and a 3 on the bottom. Last example, then I'm going to have you try the checkpoint. I'm going to flip this second fraction. I'm going to flip this one. So I end up with a 2x cubed minus 12x squared over x squared minus 4x minus 12 times, I'm going to flip that, and then I'm going to factor, just like I got done doing, see what I can take out, and remember, let me go back a couple slides here, we're always going back to these rules, things to remember about factoring. Looking to take something out. How many terms are left? Is it 2? Is it 3? Is it 4? These rules will be very helpful. Oops, get out of there. So, top, over here, I'm going to take out a 2x squared. When I do that, I'm going to be left with an x minus 6, because 12 divided by 2 is 6. Over, this down here is going to factor into 6 and 2. It's got to be a minus 6 and a plus 2. Times, top over here is going to factor into 6 and 3, x plus 6 and an x minus 3. And then on the bottom, I'm going to take out an 8x squared. So what's left is going to be an x plus 3. Start looking for things to cross out, like this x minus 6 and this x minus 6. Looks like, is that going to be right? This 8, this 2 can cancel out to be 4 and 1. This x squared and this x squared can cancel out because they are across from each other. And one quick thing I have to fix, and this is my fault. This right here, let me highlight it. My first error, cut me some slack here. This x squared plus 9x plus 18, it will factor into x plus 3, but it'll factor into x plus 6 and x plus 3. Because then this x plus 3 and this x plus 3 will cancel out. That's my fault. So, on top, I'm left with a 1 over here and an x plus 6. Over, I'm left with an x plus 2, and it looks like a 4 down here. So it's a 4 parentheses x plus 2. There is nothing else to be canceled from here, so therefore, I'm officially done. All right, what I want you to do is I want you to try this 9.4 checkpoint down here on the bottom. I will put the answers to this online, and you can check it there.